Okay, let's continue and see some code to play with the hierarchical clustering. And what I did was I load the iris dataset, and then I only I'm gonna drop the class labels so that we can perform the clustering. Okay, so this is not a common way that we use a labeled dataset to do clustering. However, this is after if we use the label data to do clustering, and then we can do the cross tabulation to evaluate the performance of our clustering work. Okay, so let me load the data, and then I'm gonna apply the standard scalar. Remember, it is really necessary to do a standard scalar because we are measuring the distances between samples and also the distances between clusters. Okay, so after we do the fit and transform the dataset, and all the features are kind of in the same range. And after that, I created a agglomerative clustering model, and then I specify I want to cluster the samples into 3 clusters. Okay, so I cheated here again. I know in the iris dataset there are 3 clusters, and then I want to cluster the samples into 3 clusters. And then I want to do the cross tabulation because I have the ground truth labels, and then I also have the labels from my model. Okay, so this is what I got. So after doing the cross tabulation, I have the those two are the ground truth label and 0, 1, 2. And then for the predicted labels, I have 0, 1, 2 again. And the problem is, for the predicted label 0, it has almost 100% of one class, and then almost 50% of another class. So in this case, it is really like this. So I remember. Oops, where's my? Okay, I should use my pencil. Okay, so if you only use x and y axis, I remember there's one class here, and then there are 2 classes. They are kind of overlapped. So if you that is the distribution of the 3 classes of the array set, right? So if you check the result, of our clustering, and you may see, okay, this one is a clean and beautiful cluster. However, this one is has one class and half of another class. So, this is not that good. So remember, just now when we did the agglomerative clustering, I only specified the n clusters to be 3, and I didn't specify what kind of the linkage I'm using, right? So in this case, I'm trying to use the average linkage. So, that is a way that I'm going to measure all the possible distances between the samples of 2 clusters, and that the average of all the possible distances between the samples will be considered as a distance of 2 clusters. Okay, so I'm trying to see if that's better, and to my surprise, that is even worse. So now the cluster 1 is beautiful, and then for the cluster 2, it has almost 100% of the 2 remaining classes. So that is not so cool. And I'm gonna just pause here because for this dataset, I would say k-means might be the best clustering algorithm in this case. Okay, because for the k-means, at least we are using the idea of the centroids, so we are going to have 3 centroids here, and then using the 3 centroids, and then we can cluster those classes probably the best. Okay, so I'm gonna stop playing with the iris data, and then in your exercise I'm giving you a new dataset, and that is the dataset of the C's. And as you can see, the ranges of the columns are also varied. and you have a column class, and that is a target class. So you want to drop that first, and then you want to do the pre-processing. And remember, you have to do the standard scaling, of course. And after that, well, I tell you, there are a total of 3 classes of the seeds. So go ahead and try different ways to cluster the samples into three different clusters, and then do the cross tabulation and see your results. So if you see something like this, and that is a very good clustering result. Okay, and then I try to play with the hyperparameters a little bit, and then I got different machine clustering models. So go ahead and clean the data and do the hierarchical clustering and using different hyperparameters, and see if you can get something similar to what I got. Okay, so go ahead and pause your video here, and I'm going to show you my solution later in this video. Okay, so well, if you're here, probably you have already finished coding your own exercise, and this is my solution. So the first thing I want to drop the class, because that is the class label. If I keep that as part of the dataset, I'm clustering the data, and then I'm definitely cheating. So I'm going to drop that first, and then I create a standard scalar and transform my dataset. And after that, I created the first hierarchical clustering without specifying other parameters. I just say there should be 3 clusters. And after that, I did the cross tabulation, and then I have already got a good result. And after that, I try to use the k-means. So for the k-means, well, they are very different clustering algorithms. But for the k-means, well, interestingly, it also gives me kind of the similar results. So what I want to ask is, well, if you have the similar results from the hierarchical clustering and the k-means, what does that mean? So let me say that question again. So this is the result from hierarchical clustering. This is the result from the k-means. So it seems that this dataset is an easy dataset. We can cluster that well enough with hierarchical clustering or k-means. So what does this mean? So think about it. So my observation is, if this dataset can be clustered with k-means and hierarchical clustering, well, it's likely that this is a easy dataset, a beautiful dataset, and there are 3 clusters can be easily identified. That's number one. And number two, if you consider the shape of those 3 clusters, those 3 clusters are in round or spherical shape. Okay, so that's my observation. And well, to do a very quick sum up, well, for hierarchical clustering, it is a bottom-up clustering algorithm. So each sample started as a cluster of only one sample, and then we just merge the clusters if they are very close to each other. So we keep on merging the smaller clusters to bigger clusters until we only have specified number of the clusters left. Okay, so that is the a brief introduction of the hierarchical clustering, and we are going to have another lecture about the hierarchical clustering. And after that, well, I should say we have 2 more courses, one on the hierarchical clustering and another one on ethics, and then we are finished this semester.